The Maxwell-Boltzmann distribution gives a graphical representation of the distribution of velocities of gas particles at different temperatures or a mixture of gases at the same temperature. And in both cases, the average kinetic energy of the gas or the mixture of gas is proportional to the absolute temperature in Kelvin. And that's from kinetic molecular theory. Now in the distributions on the left, we have the same gas at different temperatures, which are increasing from T1 to T3. And the average kinetic energy can be written as 1/2 by the mass by the average speed squared, where m is the mass of a gas particle. So in this case, because the temperature is increasing, the average kinetic energy is increasing. And given we're looking at the same gas, the mass of a gas particle remains constant. So therefore, the average speed of the gas particles is going to increase. Now in the second distribution, the temperature of the mixture of gases is the same. So therefore, for the gases in the mixture with a higher mass, they must have a lower average speed. Because given that the temperature is constant, then the average kinetic energy of the gases in the mixture is the same.